Okay, now we're going to be looking at this graph. It's a polynomial. A couple things to point out is the negative in front tells us the right-hand side is going to be down because it has a degree of 3, which is odd. The 2 will make it vertically stretch away from the x-axis. That's why it's very narrow loops. So we're going to talk first about the maximum and minimum, and we have the words local and absolute. Absolute would be where it's the highest point. Like if you go back and remember quadratic, that is an absolute max. There's nothing else above it. Whereas these points over here, this point right here, is a local maximum because there's other points around it that are higher, which have the arrows going on. So we don't have any absolutes. So the local maximum, we're going to write it as an ordered pair, is 1.67 to 1.63, but really 1.63 is the max, because really when they're asking max or mins, they want to know the y value. Again, that the local minimum is 0, -3. So now we're going to go to domain. Domain is left to right, and I have arrow on the left, arrow on the right, so that's -infinity to infinity. And range is bottom to top, arrow at the bottom, arrow at top, so that's also -infinity to infinity. Now we're going to go to increasing and decreasing. So when I'm thinking about something increasing or decreasing, I'm thinking about the parts of this graph that left to right, they're going up, and that is this piece right there. Going left to right, that is going up. So what that tells me is I'm increasing, and we use the x-coordinates here, and that is increasing from 0 to 1.67. Then the decreasing portion of this graph are the other two parts of it, and there are two, so I'm going to have an interval that has a union to designate that there are two parts. So it goes -infinity to 0, and then it goes from 1.67 to infinity. So it goes from the local maxes and mins, the x-coordinates. So increasing and decreasing is x-coordinates. Now the point of inflection is found by the average of the two maxes or mins, because it's going to occur somewhere in the middle of these two. And really, we're going to learn how to do that when you are in calculus. But the quick way to do this would be that I take my maxes and my mins. So 0 is the x-coordinate, and 1.67 is the x-coordinate of the max. I divide it by 2, and this gives me 0.083. Let me get that written right. Now I can plug that in and find the y value, which would be plugging it into -2 x squared, so 0.83 squared, cubed, and then plus 5x squared minus 3, and this value gives me -0.70. Okay, concave up and concave down means when I am opening up, and that's going to be using that point of inflection. So I am concave up from -infinity to that 0.83, and then I'm concave down from that 0.83 to infinity. That's just where it changes direction. Okay, in behavior, remember, is read as x approaches -infinity, which means as x goes to the left, y is going up, so I would say infinity. As x approaches infinity, so it goes that way, the arrow is going down, so that's -infinity. And that is basically a lot of the things that we're going to work at finding on graphs. Okay, we learned odd and even in Algebra 2, and it was basically the highest power, which it is in many cases, but there are times that you may think it's odd or even because of that rule, and it's not. So a couple other things we're going to add to this year is the rule for an even is that the function is going to be the same thing when I put negative x in it. So if I put a 2 and a negative 2, I'm going to get the same y result is what that's saying. So the way this coordinate's going to be is x is opposite than the y. And these things are symmetric around the y-axis. So if we think about a quadratic, it's a degree of 2. And both the arrows are going in the same direction. So that's also cue that it's even. That this is showing you if I put x in, I'm up at this spot. If I put the negative x in, I'm up at the same spot. So these both have the same y coordinates. Okay, an odd function is where the function is opposite, the y and the x are opposite, so negative f of negative x. So this would be a negative x and a negative y, and these are symmetric around the origin. So this is a cubic, and I'm showing you that when I go to the right x and I go up, which x and y are, but in this case, are both positive. And then if I go in the same direction, the same distance, x is negative, y is negative, and that's how odd functions are created. Okay, now we're going to think about some key characteristics of different graphs. I've given a list of things that they can have all or just some, but we'll just leave blank for the function that does not have these type of characteristics. We're going to start off with a linear function. Obviously, it's a line. The domain of all lines are negative infinity to infinity, as well as the domain. Notice I'm using interval notation. This line is odd because one side is up, one side is down, and the end behavior is as x approaches the left, which is negative infinity. Y is approaching the top, which is infinity. As x approaches infinity, which is to the right, y is approaching negative infinity, which is down. It does not have a relative max or min. The 0 is where it crosses the x-axis, so that's when x equals 4. This entire graph is decreasing, and the interval is the same as the domain. There is no point of inflection, and there is no asymptote. Okay, this next function is a quadratic. The domain of a quadratic is always negative infinity to infinity. The range of a quadratic determines which way it is facing and what the vertex is. So the bottom of the graph is arrows, so it's negative infinity up to the y coordinate of 4, and 4 is being used, so I use the bracket. This is even because both arrows are going down. The end behavior is as x approaches the left, which is negative infinity. Y is approaching negative infinity. They're both going down. So as x approaches infinity, which is to the right, y is approaching negative infinity. We have a relative max. We have an absolute max. And that is at negative 3, 4. The 0s are where it crosses the y-axis, so x is equal to negative 5 and negative 1. Okay, I have increasing and decreasing intervals, so increasing and decreasing. Increasing is the left side, so it's from negative infinity up to negative 3. Remember, we're using the x-coordinates. And decreasing is from negative 3 to infinity. Point of inflection, there isn't because there's not another curve up, and there is no asymptote. Okay, this is a root function. The domain is left to right, so it starts off at negative 2 and goes to infinity. The range is bottom to top, so it's negative infinity up to the 6. This one is neither. The end behavior is as x approaches negative 2, y approaches 6, and as x approaches infinity, y is approaching negative infinity. There is no relative max or min. There is a 0, but not shown on graph. And we don't have the equation. The entire thing is decreasing. So it is decreasing from negative 2 to infinity. There is no point of inflection. There's no asymptote. Okay, this is a cubic function. The domain is negative infinity to infinity, and the range is also negative infinity to infinity because it's arrows, 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 arrows. This is odd. The end behavior is as x approaches negative infinity, y is approaching negative infinity. As x approaches infinity, y approaches infinity. There is no relative max or min. The 0 here is where x is equal to 2.5. Has increasing, the whole entire thing is increasing from negative infinity to infinity. That does have a point of inflection, which is 1, negative 3, and there are no asymptotes. Okay, this next function is a polynomial. Domain is arrow to arrow, so negative infinity to infinity, as well as the range. This is odd because one side is up, one side is down. As x approaches negative infinity, y is approaching infinity. As x approaches infinity, y is approaching negative infinity. They have a relative max, so my max is at 3, 5, and my min is at negative 4, negative 8. The zeros are when x equals negative 8 and 6. There is an increasing interval from negative 4 to 3, and there are two parts of the decreasing interval, so negative infinity to negative 4, and also 3 to infinity. Point of inflection is where I add the x's and divide by 2, so I've got negative 4 plus 3 over 2, so it's at negative 1/2. I don't have the equation to find the y, and there is no asymptote. Okay, this one is also a polynomial. So domain again is negative infinity to infinity as well as the range. One side is down, one side is up, so it's odd. The end behavior is as x approaches the left-hand side, which is negative infinity. Y is approaching negative infinity. As x approaches infinity, y approaches infinity. I have 2 relative maxes, and I've got one at negative 7, 8, and I've also got one at 2, 3, and then my minimums are at negative 3, negative 5, and at 6, negative 7, and I can put the and sign there. Zeros, it's every place that it crosses the x-axis. So x is -8, -6, 0, 4, and 8. Okay, my increasing intervals. I'm increasing from -infinity up to -7. I'm increasing from -3 up to 2. And I'm increasing from 6 to infinity. I'm decreasing from -7 to -3. I'm decreasing from 2 to 6. I'm not going to worry so much now about the points of inflection, and there are no asymptotes. Okay, this is a rational function. The domain is in two pieces because this one does have asymptotes. So this one's going to go from -infinity to that asymptote, which is at 2. And then on the other side of 2 to infinity. My range starts at the bottom at -infinity and goes to the horizontal asymptote at -3. And then on the other side of -3 to infinity. Remember this one, you can cross the horizontal asymptote. Rationals are neither. So the end behavior is when you're approaching the asymptotes. And we will talk about this when we study. So I'm not going to get caught up so you don't get too worried. There's none of these. There is one here, but I don't have the equation. And so pretty much that's all we got. So when we get to rational functions, we'll worry about the end behaviors and how to find these other things.